What Newton's first law says. Teacher.
Is it a road? Wait, is it like in the...
Okay, tell your neighbor what will happen if a moving object has no unbalanced forces acting on it. How will it move if it's moving and there's no unbalanced forces acting on it? Tell your neighbor, and then follow up. If an object is moving, if an unbalanced force acts on it, how will it move? Okay. Hopefully you said an object in motion, object at rest will stay at rest. An object in motion will stay in motion if there's no unbalanced forces acting on it. So an object in motion, moving object with no unbalanced force acting on it will continue moving at a constant velocity, constant speed, straight line path forever and ever. If the force is acting on it, its velocity will change. Specifically, it'll experience acceleration. How do we do? Okay. All right. Next. Boop, boop, boom. Blah, blah, blah. That's and freeze off. Tell your neighbor what inertia is and what does an object's inertia want to do if the object's at rest, and what does the object's inertia want to do if it's moving.
It's gonna stay.
Okay. It's the object's natural tendency. It's not a force. It's the object's natural tendency to maintain its present state of motion. Okay. If it's at rest, then object's inertia wants to stay at rest. If the object is moving, it wants to continue moving at a constant speed, straight line path. It wants to maintain whatever way it's moving. It wants to continue that state of motion. Okay. So just tell your neighbor everything you know about this. After it leaves my hand, before I catch it. What to tell your neighbor everything. Okay. Let me just give you a little bit of an insight to this class. Everything that we have learned so far continues to build on itself. Okay, this semester is one big story of how and why things move. you need to understand stuff from the first unit, the second unit, to be able to do the third unit, and then do the fourth, and so on and so forth. Okay. So projectile motion is essentially just something in free fall. It's just moving sideways as well. Okay. So, boom, boom, boom. By the end of this lesson, you'll be able to describe the motion of something in free fall, moving both horizontally and vertically, and why it moves that way. Calculate the position, displacement, and velocity in both the horizontal and vertical directions for an object that is in projectile motion. Okay. All right. Demo 1. That in and of itself was a pretty good feat. Sometimes it's a struggle. Okay, so the marker, what is the state of motion right now? At rest. What does its inertia want to do? Stay at rest. Here we go with that. Okay, here we go. Boom. Yeah, nailed it. Thank you. All right, so did it stay at rest? No. Why not? Gravity pulled it which way? Downwards. Okay. It experienced free fall in the vertical direction. You good with that? That's not that's not the thing I want to focus on. We know that was going to happen. But what happened to the horizontal motion of the marker? Stayed the same. It stayed at rest. How do you know? It ended up in the vase. Okay. Why did it? So did it do what inertia wanted to do in the horizontal direction? Horizontally. Yes. Why? It stayed at rest. What about forces? Were there any forces acting on it in the horizontal direction? No. We're going to say no. Okay. So here's the deal. Vertical forces only affect vertical motion. Doesn't mess with horizontal motion. Okay. This is a really big concept. This idea right here. Okay. Forces in the vertical direction only affect vertical motion. Vertical forces only affect vertical motion. Horizontal forces only affect horizontal motion. Okay. Horizontal motion of a projectile motion is independent of the vertical motion. Okay. They don't affect each other. They are completely independent of each other. Okay. So horizontal motion is independent of vertical motion. You good with that? Okay. So the skill that you need to foster is to make a distinction between how something is moving horizontally compared to how something is moving vertically. They're independent of each other. So looking at a scenario just like the marker in the vase and say vertically experienced acceleration, but horizontally it remained at rest. Does that make sense? That making that distinction between those two different types of motions and the forces that cause it. Cool with that? Okay. I'll reference this a lot, but this is big. Okay. Anybody have a guess? Demo number 2. What I have here is a contraption that will drop something at the same time it shoots something horizontally. Okay. So this one's going to drop. This one's going to be launched horizontally. Okay. I will give you this disclaimer. It's pretty anticlimactic. Like it's like bloop. Like that would be so cool if it but it doesn't. Okay, so in order to discern, this one's made out of plastic, this one's made out of metal. Okay, they'll sound differently. If I drop them both from rest, which one's going to hit the ground first? Same time, right? Doesn't matter the material, size, whatever. Okay. Jonathan, I think you're going to be okay. All right. So listen for the hit. Okay. Ready? 3, 2, 1. What'd you hear? Same time. Okay. All right. So that's the fact. Now I want to know why. Okay. Hold on to that thought. We're going to unpack it together. So this is a reflection question. Tell your neighbor what you think and why.
It's in the vertical direction. They're both going down.
Okay, correct answer is C. C, the one that was thrown was moving right at the beginning, right? Which way was it moving? Horizontally. How was it moving? Vertically, right at the beginning? It wasn't moving. It was the same. Both started at rest, like the dropped one started at rest. Okay. So did the one that was thrown horizontally. Okay, so check this out. If you could, if I threw this one at you horizontally and you didn't have depth perception, it would look something like this. That makes sense? Vertically, they had identical motions. You okay with that? They both started at rest. They both experienced the same acceleration of gravity. They both fell the same distance. Therefore, they hit at the same time. Good with that? Follow-up question. Tell your neighbor. Correct answer is C. Very good. Both started at rest, both experienced acceleration of gravity, both fell the same amount of distance, therefore both will speed up vertically the same amount. Just the vertical. Another question. Thumbs up when you have a guess. Tell your neighbor. Correct answer is? Correct answer is A. Okay. This is the same question as if I dropped one from this height and one from this height. Which one's going to hit the ground first? Well, obviously the one that's closer to the ground. Exact same question. Just the only difference is I threw the one that was lower. Good with that? Horizontally, sorry, in the vertical direction, there's less distance to fall. Okay, so we've got this bowling ball. I'm going to roll off the table. Okay. Okay. Now I'm going to do the same experiment, but this time I'm going to turn off gravity. Okay, ready? Feel that? That's crazy. Whoa. Okay, we're gonna roll this off the table without gravity. Ready? How's this moving? Constant what? Velocity. Why? That's what inertia wants to do. It's going to keep on going until it runs into something to exert a force. Ugh. All right, we're going to turn on gravity because I was getting a little queasy there. Okay? Oh, we're going to ignore that as well. That's easy. Ignore gravity, we'll ignore air resistance. So when gravity's back on, which way does gravity act? Downward vertically. Is there anything going on horizontally? Any forces acting horizontally? No. So what do you think its inertia wants to do? Keep going horizontally. In the horizontal direction, was there anything that would prevent that from doing what it wants to do? Horizontally. Tell your neighbor.
Yeah. It just kept
Correct answer is? Correct answer is A. Why? There's no forces acting on it in the horizontal direction. It's doing exactly what inertia wants to. It's like, yes. While it falls, yes. Which way is gravity acting? Down, which is independent of how it moves horizontally. They are in horizontal motion and vertical motion are independent of each other. Okay. Here's a way to illustrate this. Okay. The bowling ball I'm going to just make up this number. Let's say it's moving at 4 meters a second. We'll continue moving at 4 meters a second with gravity off forever. So that's what inertia wants to do. Gravity was off, it would do that. With gravity on, it is still going 4 meters a second horizontally. Okay? It's still moving the whole time at 4 meters per second. With gravity on, though, it experiences the same motion as if it was dropped like a rock, just like what this demonstration right here showed us. Okay, so it starts at rest, and then because of free fall, it speeds up. It experiences acceleration. So this one also, in the vertical direction, experiences the same motion. So it's moving horizontally and vertically. Different marker. Okay. So if we were asked, hey, if there's a speedometer on this bowling ball, we're like, how fast is the bowling ball going overall? You now know how to figure this out. It's moving both horizontally and vertically. So to find your overall velocity, your resultant velocity, you just do head to tail, cut and paste. That's how fast it's moving. At this moment, that's how fast it's moving. At this next moment, this is how fast it's moving. This moment, that's how fast it's moving. Okay. So as it falls, is the ball speeding up? Yes. Horizontally, though, it remains constant. Vertically, it's experiencing acceleration. Catching that? It's crazy. Okay. Okay, so for this quick little thing here, notice I'm making a distinction between vertical and horizontal with a subscript y and a subscript x, y-axis, x, horizontal. Okay. I'm going to tell you this one just to make sure we're like putting good ideas in there. Okay, final vertical velocity, once here, is not 0. Okay, it needs to still be in free fall. If I dropped a bowling ball on your foot, it would hurt. Why? Because it's heavy and it is moving. Okay, not equal to 0. Initial vertical velocity is equal to 0. Yes. Okay, it's moving horizontally, straight off a cliff. It's moving horizontally, vertically it starts at rest. Final horizontal velocity, it's still moving. Okay, still in free fall, still only with force gravity. It's not after it's hit the ground. So B is the only correct answer. Good with that? Okay. All right, here's an example problem. The ball is thrown at 6 meters a second horizontally from a 10-meter tall tower. How far away from the base to the tower did it hit? All right, step 1 is draw a picture. Here's a 10-meter tall tower. Throwing the ball that way. Looking for that far. My initial spot's going to be here. Final spot's going to be here. I'm going to throw it 6 meters a second. You pick my positive directions. So I'm going to make to the right the positive x direction, and y is the up is the positive y direction by default. Okay. How are we doing so far? All right. All right. This next thing, this is really important because of this. Because the motions are independent, we need to make a separate list for the motion in the horizontal direction and a separate list of variables for the motion going on in the vertical direction. They're independent of each other. Okay. So what I'm going to recommend you do is that was rough. Make a chart. Okay. And put the variables that you know are going on in the horizontal direction, make a distinction, this mindset, what's going on in the vertical direction. Okay. So start telling me, giving me, we got two numbers here, which side do they go and what variables do they go with? Here. Okay. I'm going to hold off of that. That is true. Hang on to that one for a second. Want the 6 and the 10. I want to deal with that first. Izzy. Okay. So instead of doing delta x, I'm going to do delta y. You okay with that for vertical? Okay, vertical displacement. Now, check this out. Most of you are going to put 10 meters there. Because I have a number, I need to make a distinction. Is that positive or negative 10? Okay, it's negative. Why? It's falling down. You could say final minus initial. So final 0 minus an initial 10 meters. Okay. All right, that's the 10. What about the 6? Yep, that's my initial horizontal velocity. Okay. Now, technically, I've got a number. This is a vector. So I should technically make that a positive 6. I'm not going to count you off if you don't put the positive there. Just trying to be explicit with my teaching. Okay. So those are our numbers that have been stated. Read what else. What else do I know that isn't necessarily? And which side is that? Okay, so have an acceleration in the vertical direction of the acceleration due to the force of gravity. Acceleration of gravity is negative 9.8 meters per second squared. Good. What else do I know? Is it? Okay. Your final horizontal velocity is positive 6 meters a second. Tell your neighbor why that's still 6. Okay. Now, technically, if you wanted to do this, hopefully your conversation said the velocity remains the same. It's constant. If you wanted to not make a distinction between your initial and your final, that's fine. And just put horizontal velocity because it remains 6 meters a second, you could do that. Okay. What other numbers do I know? What other variables do I have a value for? Okay. This one right here, this is going to be a stumbling block for a lot of people. If something is thrown horizontally, then your initial vertical velocity is equal to 0. All right with that? If something is thrown horizontally, your initial vertical velocity is equal to 0. Okay? This you don't necessarily have to put, but tell your neighbor what your horizontal acceleration is and tell them why. Okay, so everybody go 0. Go to that. Okay. And I am looking for my horizontal displacement. Okay. So here is a rookie move. Check it out, man. Look at this. 1, 2, 3, 4. I'm looking for that. I'm like, awesome. Don't write this down. If you plugged those numbers in the horizontal direction into that equation, what do you get? You get 36 minus 36 is equal to 2 times 0 times, you get 0 equals 0. True, but not informative. Does not help you. Does that make sense? Okay. All right. This is a really important piece of advice here. Do not take numbers from this side and numbers from this side and try to squeeze them into one single equation. They are independent of each other. We made a chart to make a distinction between those two. If you take numbers from this side and numbers from this side and stick them into one equation, that is certain death. Okay? Is everybody good with that? Like that will not go well. Okay? So, now, here's a cool trick to the trade. Time is neither horizontal or vertical. Does that make sense? Okay. So time is the only variable that can go across and be applied to both sides. Okay. So if if I solve for time, it doesn't work out well on the side. You still get 0 equals 0. Okay. So I'm going to give you some insight here. Can I find time using the vertical side? Got 1, 2, 3, 4. So I can use this equation. But I'm going to modify that. I'm going to tweak that a little bit to make that vertical. That makes sense? Okay, plug in numbers. Okay, this goes to 0. That's like 2 points. 4. Take the square root. 1.43. Good with that. Yeah, so what? Thanks. Appreciate that. Not sure why I would need that. I'm looking for horizontal displacement. Thank you very much. Why could this be important? How could I use that? It's the only one that can go between the two is correct. Check this out conceptually. If I dropped this and shot this at 6 meters a second, it's going to be in the air for the same amount of time. Okay, I just found out how long it's going to be in the air just dropping it vertically. It's the same thing as shooting it horizontally. While it's dropping, it's also moving horizontally at 6 meters a second. So I can use that here, and that can be applied here. In the horizontal direction, you have a lot of options. Here's my suggestion. How would you describe the motion in the horizontal direction? How's it moving? Constant what? Velocity or acceleration? Constant velocity. So because it's constant velocity, because horizontal motion is constant velocity, I can use this equation here. All right, with that, you could use a kinematic equation and get the same result, but 6 meters a second is equal to delta x over 1.43 seconds. And you find that to be 8.57 meters delta x. Does that seem reasonable? Yep. Okay. Okay. Here are the instructions for cooking a projectile motion problem. That's good with that. I just walked you through. These are the steps I just walked you through. Okay. Now, one more, actually, before I give you this, questions, points of confusion. There's a lot of stuff going on. To recap, draw your picture, separate out your variables in terms of horizontal and vertical. Recognize that time is the variable that ties these two together, and then never mix these two into one equation. Time's the only one that can do that. And then figure out what you need and what you got. How to get there. Okay? Organize your work. It's a lot of stuff. Start with your original equation. Not going to be able to help you. Got a bunch of stream of consciousness. Okay? All right, one last demo for you. Okay, back here, I have a I have a little thing that when it crosses this trigger here, shoots something straight up. Okay. Okay. The question is, as I push this, goes by here, it's going to shoot it. Will it be able to catch it? Ready? For some reason, it just looks so much cooler. You know, like do it in a tunnel. I don't know why, it just does. It's just like, boop, boop, oh, there's no way. It's just, I don't know why. That's just cool. Okay, so how would you describe how it moved, how the ball moved, how the cart moved in the horizontal direction, and why? Tell your neighbor. Okay. How'd it move in the horizontal direction? Constant what? Velocity. Why? There's no forces acting on it. It does what inertia wants to do. It was moving beforehand, and then it's moving. It's still moving, and it gets caught. Vertically is experiencing free fall. Final thoughts. Can you calculate something moving along, rolling along at a constant velocity? Can you calculate stuff like that? Motion with constant velocity. If I gave you numbers. Yeah. Unit 1. Can you calculate motion of stuff in free fall? Yes. Unit 2. If you can calculate this and this, then you can calculate this. Because this is just a combination of this and this happening simultaneously. Worksheet due tomorrow.